Okay, we're looking at 10.3 arcs and chords. Okay, we've already talked about a chord, and we should know what an arc is. So what more do we need to know? Let's find out. I don't want you to write the big long book definition unless you really want to, but I have a picture here in a circle or in congruent circles. Two minor arcs are congruent if and only if the corresponding chords are congruent. So this is what I'd much rather have you write something like this down. In a circle, two minor arcs are congruent. So I might say the arc AB is congruent to, if arc AB is congruent to arc CD, then the chords are congruent. So then this has to be congruent to this. That's basically what that is saying. All right, vice versa is true too. If you know this chord is congruent to this chord, then their arcs are also going to be congruent. A regular hexagon is drawn in a circle as part of a logo for an advertisement. If opposite vertices are connected by line segments, what is the measure of angle P in degrees? Okay, so all of these, it turns out, are going to be congruent. So I've got 360 degrees, and we're going to divide by 6 angles. So that's going to give you 60 degrees. We've got a regular hexagon, basically. All of these arcs are also 60 degrees, which means all of the central angles are 60 degrees. It also means all of these chords are congruent. Inscribed. So I could inscribe a triangle in a circle. Okay, so here is my triangle. It's going to be a bad drawing, by the way. Inscribed in my circle. I could inscribe a circle in a triangle. Okay, it would look like this. Here's my triangle, and there is my inscribed circle. Okay, in the circumference books, they talked about the circumscribers. Circumscribed, or I might say circumscribe a triangle about a circle. Okay, so here's your triangle is going to be on the outside. So we circumscribed a triangle about a circle. And we can circumscribe, I should probably use a different shape, huh? Circumscribe a circle about a triangle. Okay, if you see a statement like that, that means you're doing this. Okay, whoops, that's supposed to touch. Notice how my vertices here touch. And then here it's actually kind of touching, depending on the drawing here, but we're touching the midpoints there on that triangle. Oh my gosh, do some of these pictures look the same? So in other words, inscribing a triangle in a circle is kind of the same as circumscribing a circle about a triangle. Yeah, and this will come up and up again, so be aware, we need to know the vocabulary. You know, inscribed, inside. Circumference is around the outside of the circle, so that's where I think of circumscribed. Okay, this one needs to go in your notes. You need a picture and everything. In a circle, if a diameter or a radius, they don't have to draw the entire diameter, is perpendicular to a chord. So notice how I have the right angle. Here's your diameter, here's your chord. Then it bisects the chord and it bisects the arc. So this arc is cut into 2 equal pieces. So this piece right here is congruent to this piece. Okay, so your chords have been cut in half, and, did I say chord? Your arcs have been cut in half, but so is your chord. Okay, so that's kind of a big rule coming up here. Circle W has a radius of 10 centimeters. All right, I'm going to put that in there right now. 10 centimeters, that's from here to here. Radius WL is perpendicular to chord HK. Okay, right as soon as you hear that, we can almost write in this piece is congruent to this piece is congruent to this one as well, okay? All right, so radius WL is perpendicular to the chord, which is 16 centimeters long. So the chord is 16, but I'm going to write 8 and 8. Can I do that automatically? If the measure of HL is 53, approximately, I don't like that, but I'm just going to say 53, find the measure of MK. I need to know how far it is from here to here. Well, if this is 53, then this also has to be 53. Okay, how many degrees in this total circle? 360 minus 53 plus 53 is 106. Okay, that leaves me with 254, and this is going to be cut in half because it's cutting this chord in half. So 254 divided by 2 gives you 127. Okay, so what do I need to find the measure of MK? So this is going to be 127 degrees out here. And I would put 127 here, and you could double check by adding up and see if they all add up to 360. Example 3, we're still kind of the same thing. We've got 10 centimeters. Radius WL is perpendicular. It's 16 centimeters long. So we're going to put 8 and 8. We're going to get that taken care of. Find the distance from J to L. Okay, I have to find that amount. Here is where things are going to get sneaky and tricky. We are going to have to think, gosh, what am I going to do to find this? What am I going to do to find this? Is this a radius? And this happens a lot in this chapter. Your radius may be drawn in one location, but you may need to draw it in a different location. So I'm going to draw from here to here and put 10 in. What that does is it creates a triangle. A triangle where I know 2 of the 3 sides. That does not mean I get to use 30, 60, 90 triangles. No, no, no. It doesn't. We don't know the 30, 60 right now. We just know we have a 90. But I do know that I have 2 of the 3 sides. So if I have that, then I would go ahead and use Pythagorean theorem. 8 squared plus x squared gives you 10 squared. 64 plus x squared gives me 100. Subtract 64 from both sides, and now solve for x. I get 6. So this little piece is 6 right here. All right, have I answered the question? No, the question is to find the distance from J to L. Well, if the whole radius is 10, then this little piece is 4. Okay, so that's what I needed. The distance from J to L is 4, and I think I should label it centimeters. Okay, now another thing I'm going to point out, remember how I talked about Pythagorean triples? The most common one is 3, 4, 5, but if you double it, you get 6, 8, 10. There's your 10, there's your 8. Ooh, that could have been 6 without the work. If you know your Pythagorean triples. Example 4, circle O has a radius of 25 units. Okay, so I could put 25 here, I could put 25 here, I could draw another radius and call it 25, but let's just finish off what I need. Radius OC is perpendicular to the chord, which means these are congruent. And the chord is 40 units long, which means I'm going to put 20 and 20. If the measure of MG, arc MG, is 35, find the measure of CBG. So I need to find, let me highlight that, CBG. All right, so here we go. If this is 35 degrees, then isn't this going to be 35 degrees? Oh yeah, it would, wouldn't it? This is a diameter, so if I have 180 minus the 35, then I'm going to have 145 degrees here. Isn't the central angle congruent to the arc? Oh yeah, so CBG is equal to 145 degrees. So hold on, how am I going to write this? Measure of CBG, the arc, is equal to 145 degrees. Circle O has a radius of 25, perpendicular to the chord, so I've got this 20 and 20. Once again, I have that 40 units long taken care of. I need to put my 25 in here and find the distance from C to H. So I have to find this again. Okay, this is the same kind of problem. I am going to go ahead and put my radius over here. Or if you want to put it over here, it doesn't matter. But this creates this triangle that I'm looking at. So I've got a triangle, I've got a 20, I've got a 25, and I have this x that I want to start finding. So this is my right triangle, a squared plus b squared equals c squared. All right, this is 400. And isn't this 625? Let me just double check. I always think I know, but then I'm always worried that I put it down wrong. So x squared is equal to 225. That makes x equal to 15. So this is 15 right here. The entire radius is 25, so center to the side is 25. If I take 25 and minus 15, that's going to give me 10. So this little piece is 10, and that's what they wanted us to find, and that would be 10 units. All right, in a circle or congruent circles, two chords are congruent if and only if they're equal distance from the center. All right, here's a chord, and here's my other chord, and we have this little marking here. Chords EF and GH are equal distance from the center. And what did they tell us? If the chords are congruent if and only if they're equal distance from the center. So automatically, if they tell me they're equal distance from the center, then this chord EF is congruent to GH. It's hard to write that actually onto the picture. Okay, moving along. If the radius of circle P is 15, okay, now I can draw a radius anywhere. And here's the nifty thing you might want to do, is put your radius to a corner. Let's not do random radiuses. Oh wait, random radii. No random radii. We're going to put it there to the corner of something. And you can put it right here if you would like, or you can put it right there, but I'm pretty sure just having it out there in the middle of nowhere is not going to do us a lot of good. Okay, EF is 24. Find PR and RH. Well, I'm going to put this over here, 24, okay? And I need to find PR, which is this piece. And then I also need to find RH, which is this piece. Oh, there's a lot of information I need to find in here. Okay, so this is 24. This is cutting down. I'm going to go ahead and put this 15 back in here. I'm going to put it over here on this side. Really, EF? Oh, it's 24, so this piece is 12, and this piece is 12 as well. So there's my triangle. So I've got a 12 and a 15, and this is one of the sides that I need to find. That's my x. So I'm going to have Pythagorean theorem is 15 squared. So 144 plus x squared equals 225. 225 minus 144 gives me 81, so x is equal to 9. I think that's a Pythagorean triple somehow in there. If you multiply one out, you've got it. So 9, 12, and 15. And then what else do I have to find? PR, which is equal to 9, and RH is 12. I'm thinking of something that I'm not sure that I just divided that in two. Do I know that for a fact? I might get back to you on this. I might have an addendum onto this little video that's not becoming so little. All right, example 7 is very similar to the previous one, so I'm going to have you do example 7. And example 8. Chord SZ and UV are equal distance from the center, which means this one is congruent to this one. I'm just going to mark them on there. They're both green. TX is 39. So there's my 39 for my radius. XY is 15. Okay, and I need to find UV. I need to find how far it is from here to here. Well, guess what? I'm going to take my radius and move it over here. I didn't really move it, I'm just creating a new one. So there is my right triangle again. I've got a hypotenuse of 39. I'm turning the triangle, by the way. There's my 39, there's my right, and there's my 15. And who knows what this might be? That's what I need to find out, because they want me to find U to V. Oh, but if I find half of it, I'll just double it up. So 15 squared plus x squared equals 39 squared. And this is 225 plus x squared equals 39 squared. 15, 21 minus 225 is 1296. All right, and I take the square root of that, and that is coming out to be a nice little perfect 36. That's not a negative, that's just a bad equal sign. Okay, so that tells me from here to here is 36. Then this must also be 36. So the entire distance from U to V must be 72. I don't know, did they say inches? They say nothing. So 72 units. All right, and that's the end.